Hi, I'm Mr. Huber, and in this video we're going to talk about sine, cosine, and tangent generalized to the unit circle. Well, you remember in year 4 we introduced sine and cosine and, if you want, tangent for a certain angle. Let's start with sine and cosine. Look, for a certain angle here, let's go to approximately 60 degrees. Well, it's very fiddly. 60 degrees, okay. So you can see the cosine of 60 degrees is 0.5. The sine of 60 degrees is approximately 0.8 something. Well, you could work it out, okay? But the thing is, for every angle from 0 to 90 degrees, you have a sine and a cosine. And you could measure it. Well, you remember in year 4, we drew a quarter of a unit circle with a radius of 10 centimeters or 1 decimeter. And let's say this is 10 centimeters. Well, then for 40.23 degrees, the cosine is 0.78 or something, okay? Well, you could read it off here. So it's 0.76. You can even read it off this GeoGebra document. And the sine for this is 0.65. Look here. This is the sine value. And you know, if you wanted the tangent, well, this would be the tangent. On the whole tangent, you can find the value for the trigonometric tangent. Well, you also remember that this radius is 1, okay? So if you go, if you want to work out sine, for example, then it's opposite over hypotenuse. Well, it's just the opposite then, because the hypotenuse is 1. Here, adjacent over hypotenuse. Well, the hypotenuse is again 1, so it's just the length of the red line. The line segment, sorry. For the tangent, well, you know, it's opposite over adjacent, opposite over adjacent. But, well, if you introduce this tangent, and that's why we did it, you can do the pinkish line over 1, opposite over adjacent, but now the adjacent is 1. The adjacent is 1, so that's why you can measure it on this document, okay, or on a drawing with 1 decimeter. But now let's zoom out, okay? So you could look at the whole unit circle. Let's just get rid of the tangent for the moment. So this is the whole unit circle, and we restricted ourselves back then to angles between 0 and 90 degrees. But, well, we could go on to an angle of, let's say, 130.96 degrees. Still, this would be your sine, and this would be your cosine. Let's go on to, for example, 225 degrees. Well, obviously, this is your cosine. It's negative. Cosine is negative. It's the red line is 0.71, but it's in the negative, on the negative side, so it's minus 0.71. Here, the sine is also negative, because when you zoom out, look, we're just talking about points in a system of coordinates. And this point has a negative x coordinate and a negative y coordinate. So let's zoom in again. So clearly, at 225 degrees, which is in fact 90 plus 90 plus 45 degrees, it's clear that these two lines, the red line, or the length of the red line and the length of the blue line segment is the same, 0.71, but it's in the negative when you look at the system of coordinates. So it's minus 0.71 and here also minus 0.71. And you could carry on to 300 and something degrees. Well, you could even carry on and go do more than one revolution. For example, let's go to 360 plus 45, so that would be 405 degrees. But that's the same thing again as 45 degrees, okay? So one revolution plus the angle is again the same thing as your 45 degrees. Same thing for tangent. Look, when you switch on the tangent, you can go on. But what happens to the tangent? Well, look, when you zoom out, the point of intersection will be very high up. At 90 degrees, it does not exist because this will be a parallel line. But then, when you go over the 90-degree threshold, then your tangent is now down here. Look, this is how your tangent behaves. For an angle in the third quadrant, you have your tangent up there. For an angle in the fourth quadrant, it's down here. For an angle in the first quadrant, it's again over there. And an angle in the third quadrant, it's again down here. So this is how your tangent works. So it's important to note that the blue line segment is your sine, the red line segment is your cosine, and the pinkish line segment will be your tangent. And you can find these values for any angle. So you could even do, let's say, 735 degrees. Well, what would that be? 700, so 360, 720, and 15. So this would be 735 degrees, 2 full turns plus 15 degrees. And then you could read it off the diagram. Now let's introduce the radian measure here. Look, I talked about angles here. But well, for every angle, you have a radian measure. So for every radian measure, you can find the sine and the cosine, and obviously the tangent if you want to, okay? So look, if your radian measure is 2.11, that would mean it's approximately an angle of 121 degrees. And you could find your sine, which is 0.86. So the height of this is 0.86. It's minus 0.051. That's your cosine value. And your tangent is minus 1.67. Okay, so for every angle or for every radian measure, you can find a sine, cosine, and tangent. Now look, obviously, when you go to 180 degrees, the radian measure will be pi. When you go to 360 degrees, the radian measure will go to 6.28. Well, it's very fiddly, 6.28, 2 pi. So for every angle, you have a radian measure. So if you wanted to talk about an angle, you could use the radian measure. Okay, the opening here, use the radian measure, 2.43, or the angle. Well, in mathematics, especially when you work with sine, cosine, and tangent functions, then the radian measure is much more useful. Well, in everyday life, oftentimes we very much prefer the measurement of the angles in the degree measure. That's clear. I think no one would ever say that 60 degrees is 1.06 in the radian measure. Well, you could, But 60 degrees is 60 degrees for us, and we work in the degree measure. So I hope it wasn't too difficult. See you in the next one.